Welcome to this week's lesson on creating index statement. Today we'll find out a little bit about what an index is for, what its purpose, and then how to create it as well. So I'm using one of the resources we have available to us this week to explain to you about indexes. As it explains here, it is used to create indexes and tables, and these are basically files that allow you to find data fast in your table. So indexes are stored externally to the table. They're not within the table. They're a different entity outside the table. And they are created for the primary reason of fast retrieval of your data. So in general, you want to create an index when your table is large, not when it's small. Large is a dependent, attribute. It depends on your situation. So one person's large table, another person's small table. In practice, in the business world, if a table is more than, say, a couple 100,000 rows or a million rows, you're going to want to have at least one index and often multiple indexes on the table to improve retrieval. The syntax to create a table to create an index is very simple. It's a create index statement. You give the index a name, then you say on and the table name, and then in parentheses you have the column name or multiple column names, so you can actually have an index on multiple columns together, which is interesting. I'll describe that in a bit. What you want to note here is that you want to note that when you name the index, you want to name it something that is somewhat related to the table it's being created on. So one construct is to maybe prefix the index name with the same structure, like IDX1 for index 1, and the table may have 3 indexes, so one will be IDX1, the second will be IDX2, and so forth, and then underscore, and then maybe the name of the table you're creating it on. So if it's created on the film table, it'll be IDX1 underscore film, IDX2 underscore film, and so forth for each index. That's one way to do it. There are other ways to do it as well, which refer to which columns in the table you're creating it on. That could also be very descriptive. It can lead to the names being quite long, but it's also a nice way to go. So going back to this idea of whether it's on one column or 2 columns, when it's an index on a single column, then whenever you're doing a where clause in your SQL that refers to that column, so say I indexed on a column that was the last name in the table, and I had where last name equals my last name, Mulholland. The database management system is smart enough to say, hey, rather than searching the whole table and looking at that column for a match, I'm going to search the smaller file, the index file for Mulholland. And the index file is structured such that it allows quick retrieval. It may use a binary tree methodology to store the index, other methodology as well. So it'll actually retrieve your row or rows that match Mulholland much quicker because you have an index on it. So obviously, when you build indexes, you want to come up with a strategy of which column or columns are the ones you're going to be filtering or retrieving data on in your where clause, doing joins on, and so forth, and then create an index on that. We have noted in past lessons that for primary key indexes and also for unique constraint, for primary key constraints and unique constraints in the table or on a table, there will be an index created automatically in the background to do that. So primary key constraints are enforced through an index that's created, and I'll show you that in a second in the DVD rental database. So that's a point to note as well, is that when we have constraints, indexes are created. When you have a compound index, so in this case, this one is being created on last name and first name, it suggests that the index starts with last name and then has also in it appended to it first name. So if I were to do a where clause, and again do a select from this table persons where last name equals Mulholland, this index would be useful because last name is the first ordered item in this index. It would use this index and retrieve the name very quickly. If, however, I were to say select star from persons where first name equals Jim and don't mention last name, it would not be able to use this index because first name is in the secondary position. and it won't be able to skip over this first part here in order to use the second part. So the idea is when you have a compound index, it really means you're searching on both of these in your where clause at the same time. So if I had said in my query, select star from persons where last name equals Jim and first name like J%, right? Using the like command, it can use this index because I'm giving last name and at least a portion of the first name. It would actually use this index to retrieve the data quicker. So we learned the positive nature of indexes for fast retrievals. Of course, there's a negative side as well, right? So most things in life that have a positive side, there may be some drawbacks. And the major drawback with indexes is that they, take time to create, so they have to be maintained and created. And so when you're inserting lots of data into tables, the indexes have to be constantly refreshed and updated on the fly. So typically in very large tables, what database administrators will do is get rid of the indexes, drop them before they do a major insert, do all of your inserts or updates, and then reapply the index after in one create statement again, because it is faster for the system to do a brand new create than it is to do constant updating of the index on the fly as you're inserting data. So it's a technique to be used. Obviously, the person writing that code has to be very sure that they're not inserting rows that are going to break constraints, either primary key constraints or unique constraints, because when you then try to recreate the indexes and reapply primary keys, potentially it'll error out because you've inserted bad data. So that's obviously a part of the technique to make sure that it's correct. So let's look at our PostgreSQL tool a bit and focus on the film table, because the film table is one of the nicer tables in this schema. It has lots of columns, it has lots of data in it, and it's interesting because it has the films. You'll notice that there are constraints defined, right? And one is the primary key constraint on film ID. Okay, you can't really tell from this, but there actually is an index in the background created when this is done. Okay, it actually creates an index. And if I look at the actual indexes here, you'll notice that there's 3 indexes defined. Okay, one on this full text column that's in the table. Okay, it's a very large column. Another one is on language ID, and another one on title. And title kind of makes sense, right? It's creating an index on title. We may want to search often in this table where title is equal to, title is like, title is between, maybe. So having this index on this would allow that retrieval to be quicker. Create index could be really abbreviated by just having the create index on and then having the name of the column in parentheses after. This using B-tree is not required. It's basically specifying to the DBMS which methodology of indexing it should use in creating that. I often, and most developers often, allow the database management system to determine what is the best indexing structure rather than having us decide what that is. The management system is pretty good at doing that, so I would not worry about that on your part. So overall, indexes are very useful, especially when doing reporting. They do have an overhead when doing inserts and updates and deletes, because not only are you updating the table when you do those things, you also have to update and correct the index as well. But overall, it's a balance between finding which columns you want to index on and creating that index and having the right performance overall in your database management system. Hopefully this was a helpful lesson for you, briefly, but overall what indexes are used for and how they're created. Good luck with the rest of the lesson this week, and we'll see you next time. Cheers.